All right, hello everyone. Thank you. All right, hello everyone. Thank you for waiting and sorry for the delay. Uh, yeah, but next up on our guest speaker list, we've got Mr. Edwin coming from Syria. Hello, Mr. Edwin. How are you doing?
Hi, I'm doing great. Thank you for having me.
Mm-hmm. So yeah, Mr. Edwin here is actually the founder of Surya, and in today's talk, he will be giving a talk on IoT, cloud computing, edge computing, and applications on clean energy. Mr. Edwin, the floor is yours.
Thank you so much. Let me first share my screen. I hope you can see my screen. Okay, so thank you everyone. Thank you for having me. My name's Edwin, and introduced, I am the co-founder of Surya. And today I would like to share a topic that I think is very interesting, and it should be talked more about, in the programmers community, especially with COP26 in the background, and we have an energy crisis looming in Asia and in Europe. Um, I think um, programming, software developer, tech is can play a big role in application of clean energy and a smart grid, smart energy, and we should talk more about it. A little bit about me. So I am not a programmer like most of you. I am a programmer only by self-learning. My background is I'm working in research, and then I used to work for a chip making company, and now I lead Surya together with my co-founder, and I am also a advisor for the Indonesian Solar Power Association. So what I'm gonna do today, I'm going to talk first about power system. What is it? I mean, we use um, electrical power every day, and I bet a lot of us don't really know what's behind the scene, where does the electricity that we consume come from. So let me give you an introduction to that, so we can talk more about the next topic, which is why technology is actually very, very important to power system in general, and to a modern power system where we can have something that's more sustainable, with a more renewable energy, with more efficient machineries, and a more stable grid. And then I will go to the next subtopic, trying to give you a picture of how some interesting topics in tech right now, AI and cloud computing, microservices, edge computing, are actually direly needed in if we want to enable green energy in the long future. And then again, we have a couple more minutes, after we finish with all these. Then I hope I can share with you what Surya is, what we do in this whole energy sector, and I hope you guys get interested in contributing to this a power sector. Without ado, so let me try to start with introducing what a power system is. You know, it's it's something that's a very essential to us, but a lot of us don't really know what's happening behind the scene. In fact, it's this is the most my favorite a picture that I always give in front of every talks. You know, when we see this, we can totally tell where we can find people in the world, where there's a civilization. It's easy, you can just point to anywhere, you can some lights. That's where we have electricity. That's where we have a high density of people. That's where we have civilization. So it's a it's a clear showcase that power is one of the key underlying pillar of like a civilization. That's why like I'm a little sad that like power sector is not as sexy as like a say like a e-commerce or like a robotics or like all of the other stuff, because like all of these e-commerce, robotics, AI, they're all like powered by electricity, by the power sector. Now, I think like it is also like a very, very appropriate to say that we need more sustainable power. We've seen like how global warming and like all this like a CO2 emission like it has like a directly affect like the climate of like our planet. And our leaders are currently like in COP26 trying to outline like what we're going to do in the next few years and like a couple of decades. And if we want to go renewable and therefore like have like a sustainable power, sustainable civilization, we do need tech. And like I will try to explain in a somewhat like a layman term, like why is that. So what's in the power system? Like we plug something into like our like a power socket, we get like electricity, we can use like all our electronics, our appliances, charge like our phone. Where does it come from? It's more like a general terminology for you guys, and I hope like this will be like useful in the future. A power system in general is divided into three. One is the power generation, so the turbines, solar power system, nuclear power system, coal, gas power system, etc., etc. Once power is produced, it's like delivered in a long over the long distance into by like a system that's called like the transmission system. So if you look outside and like you see like a really tall like a power lines, that's a transmission system. It's gonna be power gonna be brought over like from over like a large distance to like cities or like to towns or like to industrial estates, and then like there like it would the cable gonna go down and like start to be distributed to like the consumers, to us, to our homes, to our offices, to public places. That's called distribution system. Okay. Now, just to give you give you a picture, this is a contemporary power system. We typically have a group of like a power generators located in like a certain areas. They all go through like a one or like a few transmission system, and then it will just be distributed. Okay, so and then like in a modern power system, this is like what we want to achieve. We don't only have power generations on one side, but we also have like a power generations like on rooftops, for example, like using like your rooftop like a PVs, and then like we also have like a storage and batteries, and believe me or not, we have to have IoTs, we have to have like a data centers to support all this. Okay, don't worry about it. Like I'll go over this and like hopefully like you can get a picture of like how everything gonna come together. So why is technology needed in the energy sector? Um, it's simple. Power system is finicky. Okay, so everything in a power system is connected. Uh, if you're a physicist or like a chemist, we say like it's always in dynamic equilibrium. It never goes static. Okay. I think the easiest way to think about it is like water pipes. Like if you like me, like live in a small apartment, it's here for like a few people, and then one day you must have experienced this. You take a shower, and then like someone like in the kitchen like turn on like the water and like to their own stuff, and then like you can feel like the water flow like start dropping. Yeah, that's what I mean by finicky. So power system is similar in the sense that anything that happened like in one client, for example, say like you turn on an appliances or something, actually affects like how your neighbor receives power. in the easiest sense, you consume like some of the power. Now like the amount of energy that's available to be used by everyone is not infinite, so it will go down. So there is a there's a higher chance that like you will get a blackout because there's not enough power for everyone. If your appliances like impact like the power quality, then everybody like will see their power quality like it goes down. Likewise, if there's an over or under supply, because for example, like someone like use too much power, then the generator also like feels it. It will be like a force to like generate more. If not, then the generator like will stop cranking or like go out of phase and whatnot, and it will cause a real blackout because like it will stop spinning. And lastly, of course, like if something happened in the transmission or distribution, it may impact the whole system. Give an example, like in 2019 here in Indonesia, we had a major like a blackout where like a tree grow a little bit too tall and like start hitting like a one transmission line. It caused an instability over like the whole island of Java, and it caused blackout not only in that branch of the transmission, but it caused like a waterfall effect into like the generators, and then like they have to like turn off the generators and then like restart like the whole however like a many generators like a one by one, and like we had an almost like a 1 day blackout like for that. So it's finicky. Whatever that happens at one point in the whole system can actually like impact other parts of the system. How does it have anything to do with tech? Well, let's take a look at the problems of the contemporary power system. And then like after that, we're gonna go to like a what's the solution, and like at the very end, you will see why tech is critically needed in order to maintain like a this stability. Okay, so the first one is inefficiencies because of a slow response. Okay, what do I mean by that? Well, if I'm like the grid operator, like a utility power, um, they don't have like any control over like the demand. They don't have like any control over like what you use at your home. The best they can do is like a guess how much power will be used at certain time of the day by everybody that's connected in the grid. Okay, that leads to inefficiencies, partly because generators are like working like a really slowly. It's basically like a giant motor, like similar to like the motor that like we have in our car or like in our like a motorcycle. It's just huge, and then like instead of like a turning like the wheels, it's turning what they call like a generator. It's turning like a mechanical energy into electrical energy. That process, if we do like a ramp up like the power or like a turn down the power, is actually pretty slow. Typically, it takes about a few minutes to a few hours to ramp up or like a ramp down. So the operators, the grid companies need to guess how much like going to be used, and then like, they put a buffer or like what they call a reserve. If those reserves are not used, they will just dump the energy away. So inefficiencies. Two, we also have a problem of like a few points of failure may bring the whole grid down. I gave you an example of like how one tree that grows like too tall and like hit a line in Indonesia, I feel like it brought down like the whole system for one major island. Similar thing can happen say like in the distribution side, or for example, like if you have a malfunction in like one of the plant, then like the other plant like it has to increase like their usage. I mean like their generations, and if they go to oversupply, then like it will cause like instability. Lastly, of course, we want renewables because this is not sustainable. We don't want to like keep burning coal and like gas and like oil because it's doing like a bad stuff to like our planet. So how can we solve like all of these? A modern power system, it must include renewables, It must include distributed energy generations and storage. It has to have a smart grid, and like this is where like a technology like will play a role. And then some of the generation must be done on the consumer side. Let me try to explain why. So I will first tackle the problem of the reserve. Like I said, typically speaking, like we put a reserve or like we produce more than enough because like we don't know like how much will be used at any given time, and then like if we have excess, we throw away that energy. That's what they do. So one way to like make this like more efficient is like to put storage. Storage can be battery. That's like what we are most familiar with. There are some other forms like of other like storage, like a dam, for example, or like a turn wheel, or capacitors, etc. So the idea is now instead of like throwing away the energy, you can just like store it in this like storage for like a temporary, and then you can reuse like these stored energy at some other time, or you can like take away if it's a battery and then like distribute like some other place. So that's an increased efficiency that will like typically really help a lot. Of course, like I said, we want to go renewables. So, for example, like we have PV, we have wind, we have like hydropower, geothermal, etc. In the case of PV and wind, we have a special case. So PV and wind really depend on the sunlight, the availability of sunlight, or like the availability of wind at any given time. So we call it like a variable renewable energy. For example, like at 7 p.m., I mean like at 7 a.m., we have like a little bit of sunlight because like the sun just like a rise, and then like it will go up, and then like it will get a lot of like electricity like generated like at noon, and then suddenly a cloud came, and then like it covers like the sun, and then like the energy like production goes down, and then the cloud passes away, and then it goes up again. So the energy generation become variable. If you're a grid operator, this poses a unique challenge because now not only you have to predict or estimate what's the client's or like the consumer's like consumption, now you have to predict what you produce. You have no control about like on like what you produce because it really depends on the weather, local weather, like at any given time at any given place. So typically speaking, whenever like we have PV, especially like a large scale PV or like a wind power, we also have like a storage like on site just to do exactly the same thing. You store like an excess, and then like whenever like it's needed, you can like a patch like a whatever like you lost. Okay. Now it still hasn't solved the problem that you have like a one point of failure. For example, if something goes wrong with the transmission system, then the client will be isolated and like they will not have energy until like the transmission line is already fixed. The most common way of doing solving this problem is like by having like a redundant transmission line and distribution system. However, with the growth of rooftop PV, like where you can put like photovoltaics on top of your rooftops, this has become a trend. You can just like install like a rooftop PV. You are connected with your neighbors. You have batteries. So now, like in the event that like some part of the town is isolated, you can actually or theoretically supply energy to your neighbors, and for the next like a few hours, that whole section is sustained, and power, uh, like you won't lose power until like the battery is depleted. That typically like give enough time for the electricians to like work on a transmission line or like wherever like the point of failure is. This is what we call like a distributed energy generations. So now not only like energy is generated in one specific place around the generators, it is also like a generated uh, on the client side, the prosumers. It's not consumers anymore, it's a producer consumer, so it's prosumers. So this is like what we have been like aiming for, like a high energy reliability. There is one big problem about this. Now we have like so many assets distributed like over so vast area. How can we manage all these? Because before we have like a one generator. We just need to assign some people in that generator. We have like a certain like a points along the transmission lines. We just like assign like some technicians to like a service that line. Now we have generators everywhere. We have a network of like a distribution, and we have tons of assets everywhere. How can we manage all that? And this is why technology is very important. IoT is going to play a huge role in like a modern power system. The same with like a data center, the same with like a cloud computing or like an edge computing, which I will talk about like in the next part of the slides. So what are these like opportunities in the energy sector? Okay, so we want to keep the key metrics for a power system is like we want to keep it cheap, we want to keep it reliable, and we want to keep it sustainable. That's why we want to move to that like a modern like a power system. But like I said, if we have like so many assets distributed like everywhere, it won't be cheap, it won't be reliable, and it won't be sustainable if we have to like send technicians for every single place and like we have to like manually like record everything. There are three tech challenges in a clean energy or like in a modern power system. And this is just like in my opinion. One is cybersecurity. So if we want to put technology or like we want to enable like a technology like in the power system, cybersecurity is really important because again, it's a critical infrastructure. It is something that's fundamental in our civilization. If you're becoming like ethical hackers, this may be like a very interesting a topic for you guys. Basically the same thing. How can we prevent like a malicious agents from taking control of the system, keeping you hostage, making sure like that you don't get like any power can be detrimental to even a nation. And then like if such thing occur, how can we respond to that? How can we minimize the damage? How can we make sure that we don't become hostages to like all of these malicious agents? The second one is something that probably being talked about in COP26, planning. How can we transition to this? And a lot of like the renewables, like I said, really depends on like the weather patterns, both like wind power, tidal power, like a solar power. Modeling a system that's as complex as a weather requires a lot of analysis, requires a lot of like machine learning, requires a lot of like AI. The same with the grid updates. You've seen like how complex it is. There got to be a model. There got to be an extra power like for modeling like all this, so like we can plan for like a sustainable transition in energy. Google actually just like a launch what they call it Project Tapestry. It is a modeling for a power system like a planning. So it's a frontier like a technology right now. What I'm going to talk about right now, however, is tech-driven efficiency. Um, Something about smart grid, smart operations, and last but not least is like a smart home. I'm not going to talk about it because it's more about how to save like energy and like like reduce like your carbon footprints. So one of the way that like cutting edge technology can help is like Internet of Things and helping like the power asset management. Like I said before, like now, if we want to move to this like a modern power system, we're dealing with like a vast amount of distributed assets. There's no way like we can do like a conventional way of like assigning technicians to gather data, to check the status of like every single asset, making sure like everything's like working like perfectly, and flip a, or even like a flip a switch. What if something happened like a real time, and then like we need to turn a knob, not in our plant, but like somewhere else? What if there's a problem that's catastrophic, and you need data from like a multiple locations in order to find out like what is wrong? IoT like it enables like a remote monitoring and remote control of like all of these distributed assets. So this will become like one of the backbone of like a modern technology in a modern power system. Cloud computing. This is another one that like it's not being used a lot, or at least like in developing countries like such as Indonesia. You have so many distributed assets. It's spread over like a vast geography. What if there's like some disconnect between like people like working in like a one region compared to another region? Something as simple as, why is my data about this plant is different than the data that you pull? Or how about like the firmwares? Why do I need to do things in a certain way here, but I cannot do the same thing like in some other place? Or even like or protocol, like you some people like do certain stuff in one way here, but like do things like differently like in another place. That's really counterproductive. So cloud computing can actually like help, and like we have an experience in cloud computing that like it can show that like yes, we have it really helped our operations a lot. With cloud computing, we can have a unified protocol, we can have a unified software infrastructure, and of course, we have a single source of truth of data. So everybody's like talking the same thing, even though we are managing a vast number of distributed assets over vast like a geography. The third item that I think is very important is edge computing. So one of the key aspects that like we need from a good power system is reliability. So critical availability is very, very important. You don't want, your power to be cut off like at any given time, even like for a second, right? Otherwise, you lose internet, you lose like your TV, or like if you're in industry, it's even like a worse. Like power outage will damage like your output. It may even like have some detrimental effect to your equipment, and it can make you like lose a lot of money. And one of the key problem of like a cloud computing is that latency. So suppose you know that there's a problem in one place, 1,000 kilometers away, one island away, cross province or cross states. You want to like fix that problem. You send a command from your headquarters or like from like the server. Unfortunately, it will still take 1 second, a few hundred milliseconds, one way to reach like the problematic like part, and then like it will still like have to decipher like the message, and then like do things before like the problem solved. That 1 second or like a 100 millisecond may be the difference between the systems like going out of like the stable regime and like the system still running okay. So latency is a problem in general. And it's not only, even like if you have, because the system is like it's really finicky, if you have like a latency around like a certain area only, it will still able to like bring down like the whole grid. Edge computing is a paradigm where like some of the computation is done very close to where action is happening. So for example, at the power plant, or at the distribution center, or at the battery storage, or actually like at the rooftop PVs. So when we have cloud computing and edge computing, the typical paradigm is like you store like some configurations. So you empower like this like edge computers to do its own independent stuff. In whenever like there's a problem, you can do this like by sending configuration. So you tell like the edge computer to do certain stuff if it sends some like inputs, or like how to react if there is a grid down or like anomalies in the frequencies or something like that. What's stored in the cloud and like what's managed in the cloud are the configurations. You send a configuration to the edge, and then the edge computers will execute depending on like the stimuli like that it sees at that given time. So edge computing solves latency. It also reduces bandwidth because data is data is cheap, but it's not that cheap if you consider like a large amount of data like being like sent here and there. And more importantly, what happens if your internet's down or the system's isolated for like whatever reason there's a system failure? Edge computing will still enable power to be served in this kind of like a situation. So edge computing is very important for both latency and to help us ensure high availability. Lastly, of course, like the big words like that have been used nowadays: machine learning and artificial intelligence. Most of the machine learning and artificial intelligence that like I've seen so far are like for forecasts. Like I mentioned before, we need to be able to forecast the demand or like how much like people will use electricity at any given time of the day, and like therefore like we can adjust the power that's being generated accordingly and minimize like the reserve. But now like with the renewables, we also have to like start to predict what's the renewable energy generation pattern at any given time. We compare it with the weather data, we compare it with like historical weather data, and then we try to predict what is the production, say like 15 minutes from now. Sometimes we even have to predict crazy events, and this really happens. I heard like one of my colleagues who work in Europe, they have to predict seasonal bird migration because it will affect their photovoltaic output. So huge flock of bird, they sometimes like during the seasons, like they will like pass by like their solar farms, and it will reduce like the power of the solar farm for like a few minutes, and that again is enough to bring the whole grid down, um, even though like they have storage and everything. So they have to be able to predict that by using like various cameras that like a place all over the place, and some uses like a satellite imagery too, and like trying to predict like where the bird gonna fly in the next like a half an hour or like 15 minutes. Okay, so machine learning and artificial intelligence has been like widely used for forecasts, um, especially in Europe and like in USA and Australia. Um, in developing countries, this has to be used more often if you want to go to like energy efficiency. So in summary, I hope I have shown you that there are a lot of ways that we programmers can actually like employ cool stuff like frontier technology to help like clean energy adoptions. One, we have like distributed assets. This can be solved with like Internet of Things. We have to manage like a huge number of assets with like a huge number of users, and like we need some kind of like a unified protocol and data, and like this can be solved by like cloud computing. Latency and bandwidth can be solved by like edge computing, and then like this complex forecast of demand and like renewable energy is requires machine learning and AI in order to be be optimized. And lastly, if we want a high availability of like a power, high quality power, then we definitely need edge computing. And probably like on the software side, we also need like a multi-cloud to provide the redundancy as well on the software side. I still have like a few minutes, so I will like share a little bit of like my company, Surya, who we are, what we do, and probably like a little bit of like these software development that we do. So we are a company based in Indonesia who focuses on rooftop solar on commercial and industrial building. We totally believe in a clean energy for Indonesia, and like we believe that distributed energy is a solution to our current power problem. And lastly, we also believe that renewable energy should not be expensive. It should save you money, not cost you more. And that's why like we were the first one who bring uh, basically like a no capex like options for rooftop solar. We grow really fast in 2018. We were founded like in 2018, about 3 years ago. We initially have only like a few sites in Jabodetabek, which is like the capital region, and like just two back then, like in East Java. We grow to a few different islands. We start to have like our first site in South Sumatra in I believe like late 2019, and then like we also have like another plant in Sulawesi in 2020, and then like even during COVID, we still grow. But like I think like this is very optimistic. Now we have sites in Lampung, North Sumatra. We have a few more in like Banten, West Java, and like lastly also like Central Java. So we see like strong growth. We see like a strong demand for renewable energy, and like more passionate people actually like applying to like join us. Our sites include like I said, like a CNI, commercial industrial buildings. We have, for example, warehouses, this MGM Bosco and SNJ. We have school, for example, like Golden Sevilla. We have hotels, and like we have factories such as like the SCB. This is a steel factory. Food factory. We have like some subsidiary of like a Toyota. We also have like other factories, and including like the second largest rooftop solar plant in Indonesia, which is located in like Gresik. And I just operated like late last year. Right now, we have installed close to 50 projects, and we are in the process of like installing another, probably speaking, like 50 more projects. And like I said, we do care about the environment, and like we have like avoided like a lot of like greenhouse gases, equivalent to like about like 18 million like a liter of gasoline. Like if you drive a car, roughly speaking, 300,000 trees planted, and the electricity that like we generate per actually this is like per 28th of October was enough to like power about 18,000 houses for one whole year. And like I said, so we also employ some computer science and computer engineering graduates as well, because we have to build the infrastructure that I told you before. We have to build like our IoT. We have to build like our cloud computing processes, and so we have like a really diverse background for our team. They're all highly collaborative. Most of them are still like from the technical graduates, and then like about a quarter of us are like from non-technical graduates. But we are united by our passion in like a clean energy. Um, some of the technical job roles at Surya. we have like executives, so we have analysts, of course, like engineers and managers. We do have like operations, and like we also have maintenance, business development, and of course, like we do have like programmers as well. Um, we got to interact or like use like different platforms. We use Google Cloud Platform, BigQuery, use Kubernetes. We also have make like our apps like for remote operations. That use like a Vue.js. Flutter is a new favorite for our front end engineers. We also do like a lot of like a Python in the back end. Odoo is like one of our platforms that like we use a lot. Integrated like with like all of these other like cool stuff such as Trello, Google Suite, and etc. So I guess that's all that I would like to share with you. I do hope that what I share today can motivate you to also like contribute in the energy sector because energy sector really needs programmers like you guys. We need you need to drive the efficiency and the reliability of like our energy supply, especially in the developing countries. So don't think us as not cool. There are a lot of things that can be done here. With that, thank you for your attention, and I leave the floor for like a Q&A. Thank you so much.
Thank you so much for your wonderful insight, Mr. Surya.
Yeah,
Yeah, but hold on. Is that echo coming from your end or my end?
I
Okay,
don't
never
see
mind.
any echo. Do you hear any echo?
Never mind. I think it might have been an issue on my end. But yeah, I think I've got one question that I wanted to ask myself. Is there a way? Are you guys opening up for internship positions? And if so, is there a way for our hackers to contact you if they're interested?
Yeah, I mean, we have like a few interns already. Most of them are like in engineering position. However, mid last year we had our first software developer intern, and
Mm.
it was a great experience for us. And I think like starting like the next quarter, like a quarter, first quarter of like a 2022, we will start opening up like a more internship position in software development.
Awesome. But just a little follow up to that question earlier. Um, like as a software engineer intern at Surya, what would be the things that they would focus on? Like what are their job responsibilities and all?
Most of the time, like we will be developing like a new we call it modules, like for a lot of different stuff. One of the big modules that I can tell you right now is like, of course, like our ERP system. That's all like a GCP based and like a Odoo based. We also have we use a third party like IoT hardware, and like we basically like make an interface to like interact with this IoT hardware, and then like we do automation to do data analysis, forecasting, and all that. We also make apps actually like for mobile apps. So the idea is we have lots of like a different assets like spread like all over Indonesia, and there's no way like we can operate smoothly if we cannot, you know, like if we cannot communicate with like people who are on site, and then like we cannot control them if there's no like a two-way like feedback. So we make an app that that help us like to do all of that as well. Um, yeah, I mean, like those are the kind of stuff that like we are working on. In the next year, we are hoping to like gather like by next year, like we should have like a more like pictorial data, and like we can start to do like a machine learning and like machine vision and like all that.
Awesome to hear. So yeah, I guess you guys have like all sorts of different implementations when regarding in programming. But Yeah. I'm gonna open the floor in chat, so if anyone has any questions, they could just throw them in the chat. But yeah, I think I've got one more question, one personal question actually.
Of course.
Uh, I saw on the like one of your first slides that you were actually a MBA graduate from Berkeley, if I'm not wrong.
No, I'm not an MBA. I
Oh,
was
you're
a
not.
physics graduate from Berkeley.
Oh, a physics graduate.
Yes.
Oh, okay. Yeah,
Yeah.
because my previous question was gonna be about why did you choose to go to the energy route as a business major? But it turns out you're a physics major, so it made like a
No,
lot more
I was.
sense.
Yeah, I was a physics major doing something that's totally different. And then like I went to like do physics again when I went to Colorado initially for something that's totally different again, but then like it moved to development of like a solar cell. And then like
Mm.
it, my interestingly enough, my the outcome of my research become a patent. And then like the patent is not used in solar power, it's actually used in, or the derivative of it is like used in Samsung Galaxy Fold. So a lot of stuff that that you go unexpected. Let's just say.
But ultimately, what made you decide to stick to the path of going into like the energy route and like finally founding Surya and all?
I think it's a long story. I was in the U.S. back in 2009 when like they start like a transition into like clean energy. I saw like how hard it was to like like adopt like a more renewable energy. A lot of like companies failed back then.
Hmm.
We didn't have as much like a machine learning, AI, IoT, you name it. And then fast track to like a 2015, 2016, my co-founder and I start to see an opportunity in Indonesia to start basically something that's similar. We model Surya really similar to what they used to call Solar City. Now it's called like a Tesla Energy. So we were a pioneer act. Basically, it means you don't need to pay for your own solar system. You just lease it from us. It's like you pay for the energy that we produce, and that's how like you pay for the system. So you don't need to pay for the system itself. We brought tweak it like a for local flavors, and I think like it's going well, and we believe that this rooftop PV really is the way to go in Indonesia if you want to really go big.
Awesome. Love hearing about your vision and the inspiration you had when founding Surya. But yeah, I don't think there are any questions in the comments right now. So if it's fine with you, we could end it now. Do you have any closing remarks that you would like to give the audience and all the hackers?
Um, I think like well, let's just say there are a lot of opportunities for software developers like you guys to solve a lot of problems in the energy sector. It's a very important sector. It's a one of the key infrastructure for like any civilization. And unfortunately, we don't see too much technological upgrade.
Mm.
So if you can come solve a lot of like our problem right now, I think eventually it will greatly benefit humanity. I know it sounds too great, but I totally believe in it. So good luck, and I hope to see one, two, or like a lot of you here one day.
Right. Thank you so much, Mr. Edwin. So yeah, I really hope your passion for energy, goes all the way to all the hackers we have in this hackathon. So yeah, I think with that, that'll wrap up our talks on Saturday. So yeah, you guys all have another 24 hours remaining to submit your projects, and yeah, with that, I will put this stream to an end. Thank you, Mr. Edwin.
Have a good one. Thank you for having me.
Same here.